exclusive time of functions. Today's task is 6.3. So today's Leetcode task is 6.3.6, exclusive time of functions. Let me quickly read this problem. I'll try to grasp it as fast as possible. Okay, so let's try to solve this problem. We have, let's check the example. We have zero start, zero function number 0 start at 0, and then we have start at 2, and then we have 1 and at 5. So 5 minus 3 gonna be minus 2 gonna be 3 plus 1, so 4. Yeah, 4. And at 6, so it's gonna be 7. No, not 7. Okay, so it's so we don't count this intersection. Okay, in this case we have start and 0 starts at 0, and then 0 starts at 2, and then 0 ends at 5, and then 0 starts at 6, and then 0 ends at 6, and then 0 ends at 7. Okay, let's draw this example and check if I can come up with approach. Oh no. Okay. So we have this time range, time, and we have 0, and then we have 1, and then we have 2. Have a 0 starts here, 0, and then at 2, 5, and then 0 again starts here, and then at 6, 1 starts. So it's like continuous 0, this one continues here, and then 1 starts at 6 and at 6. This is 1, and then 0 and at 7. So the output should be like 0, 8, and 1, 0. No. Okay, so like if we have um different, so if you have like something like this, it's gonna be like this, and then 0, 0, 7, and 1 gonna be 1. So my idea is gonna be currently every time we gonna every time we see the start, we're gonna push like pair like task ID start to the stack, and then every time we see an end, every time we see an end, we pop the pair from the stack, subtract, we pop it. So we pop, let's say, ID and have pop ID start, and we have current, its ID is the same ID, and then end. So we need to subtract end minus start plus 1, and we subtracted that. We probably will add the delta equals delta. We add delta ID val equals val plus delta in our kind of mapping array for the all functions time. And then what we're gonna do? And then we need basically to maintain somehow this delta for the previous function that was called there. And we need somehow to kind of decide whether you need to pass it back this overlapping interval or keep it on the same level. So let's assume we have this time and we have like here 1, 2. So let's consider this example. So if you push on stack here, like 0 starts at 1, and then we'll have a stack, and then we have stack equal 1 starts at 2, 0 starts at 1, and then our stack is equal 2 starts at 3, 1 starts at 2, 0 starts at 1. So we find we pop the element here. So like we have like element. So currently 2 ends at 4, and we have ends and starts 2 starts with 3. It's 5. So here is 5. Starts at 3. No, let's have this. So here 4, but here should be also 3. And so we subtract start end from the start, end minus start plus 1 gonna be 1, and we put there our mapping to duration 1, and then we need somehow pass this 1 duration to the previous element, and so if we'll just save this minus like current overlap, and the overlap we save like equals 1. Okay, so like anytime we can have like this and this overlap interim variable, so anytime we're gonna have one function, and this overlap will just increase. So here like we have like increase overlap by 1, and we figure out what's the total delta here. We popped it, and we increase overlap. So overlap here gonna be 6, 4, 6. So here let's say ends at 5. So like this is 6, 5. So it's gonna be overlap 2, and here overlap gonna be if it's 3, so it's gonna be also 2, so the 5 gonna be overlap, and the overlap variable gonna be pushed down, and here already we have end at 7, so, at 6, so it's like 7 here, and 7 minus 6 minus 1 plus 1 gonna be 6, and minus 5 due to overlap, so it's gonna be like 1 for the 0. So like 0 gonna be updated as 1. Yeah, so like because this exclusive time, we need to just have this common variable accumulator, like overlap, let's call it overlap, and we're gonna increment it and always push it down so that any function that's affected that's gonna be like basically queried later, or like exited later. It's gonna be overlapped. It's gonna be subtract this overlap range from its own duration to get its own duration, something like that. And so the time complexity of this, so we'll have the stack for keeping to keep function starts, and we're gonna have this algorithm that takes of an time and space also of an Potentially, I can reuse this list and hope there's gonna be array list. And yeah, but it's still. Okay, let's program it. Stack integer equals new stack. Oh, so we need to keep like say pair, and then say we have a result. We need to check if let's say yeah, potentially we can always write the string into the logs. So I'll write it and have a stack just in this stack that just organized in these logs and like convert back and forth like but let's check. Okay. we'll have like this interim variable overlap. If you'll have this kind of function 0 starting 0 and then here 1 and then you'll have 1 starting at 1 and then you'll say 2 and then you'll have again 0 to 3 and then have 1 then maybe 4 and then let's say 0 continuing being like at 5. So if we do this, we'll have like a 0 start and then you have 1 start at 1 and then you have start and start and then you'll have end 1 at 1 and then let's say start 1 at 3 and then we'll have end 1 at 3 and then we'll have end 0 at 4. So in this case we pushed initially stack it's called just as equals 0 0 and then stack equals 1 1 0 0 then stack is equal we end it so we pop it from the stack 0 0 and we subtract 1 minus 1 plus 1 so the 1 task 1 becomes 1 duration and we have overflow equals 1 overflow equals 0 overflow equals 0 then we push stack becomes 0 0 and there on the top 1 3 and then we pop it stack is equal yeah, this variable overflow it's kind of messy. In this case we just will pop the element from the stack. We'll have like 1 3 1 3 and have 1 3 and then and 1 3 so 1 so 3 minus 3 plus 1 can be again 1 so we need basically to add 1 and subtract the overflow and and the overflow will be 1, but it's the wrong one, yes. So it should be somehow different. Overlap, this function overlap, this label overlap, it should be different, not like this pass-through variable, because pass-through works here, but in this case it will not work. So whenever we have this overlap, it basically overlaps with whatever we have like open intervals in a stack. So this overlap, in the end, it affects like whatever would be in the stack down. So it's just interval 0. I wonder if I can have the same kind of overlap function, or like maybe push it with this additional variable to the stack. So we have overlap 0 here. Every time we pop element, we also pick the top, the previous one, and we update the overlap, and then we carry overlap to the lower levels. Okay. we do this start and we do this out. Okay, let's continue solving this task. I was thinking about this problem for a couple hours, and I was thinking about why this kind of sequence is not supported. Like we have like sequence function 0 spawning in the entire life of this problem. Then we have one function 1, then 2. Then we have like sequence 0 come back, but it spawns across different across different functions here. And I was wondering if this is can be the problem, or like if this can be the case in this problem. And let me find it if it's true or false. So I assume it's not possible because that will mean that this zero function call will mean that basically we are breaking the scope where it was called. So the scope of the function zero to be called is like function escaping the scope. So the scope when the function 0 is called is function 2, but it actually spans to function 0, then the function 2 again, and function 1, and it means that basically it's just the function escape is the scope, and I assume this is not allowed based on the problem statement. Um, so I wanted also to save instead of saving like start and end in the array. I also wanted to save the overlap. So like here we have like uh, we pop the like what we do here. Let me show you this. So we pop like this 0. Let's say this is gonna be 0. It's gonna be this. We're gonna be like 1. It's gonna be like 2. It's gonna be like uh, let's say it's gonna be 4. It's gonna be 6. Let's say it's gonna be 7, like 8, and that's gonna be 9. So the sequence in this case gonna be function 0 start at 0, then function 1 start at 1, then function 2 start at 2, then we're gonna have let's say like this gonna be end at 5, and this gonna start at 6, and that's gonna be started at 7. So function 2 and at 3, function 1 and at 4, function 1 start at function 1 start at 6, function 2 start at 7, then function 2 and at 7, function 1 and at 8, and function, I'm saying 8 because like we have this notation when it ends at 5, like here. When it ends at 5, it basically ends like in the end of the 5. Yeah, and function 0 and at, let's say, 9. In this case, we're gonna start one by one. So I wanna save also overlap with the pair of start, so that every time we can like drill down the overlap, like we move the overlap into the lower level, so that the we count only one function that's gonna be on the first from the start. Yep. So for the stack, how we're gonna process like this sequence? So initially, we'll have like stack equals uh, 0 start. So index, this is gonna be index, that's gonna be a start at 0, and then overlap is 0. Then we're gonna, on the pointer pointing here, we have stack 0, 0, 0. I have function 1, start at 1, overlap 0. Then we move our pointer next to 2. Our stack becomes 2, and it starts at 2, and overlap 0, and then 1, 1, 0, and then overlap 0, 0, 0. And next one, we're gonna okay, next one we're gonna be pointing to the end of function 2. So I'll be saving stack here. End of function 2. So stack becomes, so on the stack on the top we have this function 2 at the start at 2, and then end pointing to 3. So we okay, so we pop this element, pop. So stack becomes 1, 1, and then we add the overflow. So like the top element in the stack is gonna be like the length, the duration of it. Like it's gonna save the separately the duration of like of the function 2 is gonna be end minus start plus 1, so it's gonna be 3 minus 2 plus 1, so it's gonna be 2, so the duration is gonna be 2, 2, and then we add this duration as a overlap to the element that's on top of the stack. So we modify the top element of the stack as equal to, and then 0, 0, 0, and then we move the pointer to 1 again, and we pop the element from the stack, and it can be like end of it, so the function, so the function name, the function index is 1, the duration is like we have ending at 4 here, so 4 minus start, so 4 minus 1 plus 1, so it's going to be 3 4 and minus overlap what it has, minus so 4 minus 2 going to be 2, and we should basically add the duration. We popped the top element like this one, and we should add the overflow equals the duration of this function here. So the duration was like 4. So we added not overflow, but it's overlap 4 to the function 0, and then we move our pointer to next record. We move to there. We have start 6, so we push element to the stack. Stack becomes like 0 0 4, and then here we have like 1 and starts at 6, and we have overflow 0, and then again we have start at 2, we again push the 2 to the stack, so we have 2, start at 7, overflow 0 1 6 0 and 0 0 4, and then we push the index further. So we have end again, so the end we pop the element from a stack, and we update the mapping, so like it's end at 7 and started at 7, so like the duration is 1, so we add to duration 1, and we add the overflow to the whatever head of the stack, so we add like overflow equals duration, so it's 1, then 0 0 4, and then we move the pointer. Again, we pop the element, we have like ending at 8, so it's going to be 8 minus 6 plus 1, duration going to be 3, but there is overflow. We subtract the overflow, 3 minus 1, 2. We add 2 to our total duration, plus 2 here. And then we should add the duration to whatever is on the lower element, on the first element after we push it. So it was 4. The duration was 8 minus 6 plus 1. So it's going to go 3, so it changes to 7. And then again, we move our pointer here. We're gonna have like 0 and at 9. So here started at 0, ended at 9. So like 9 minus 0 plus 1 gonna be 10. But we need also to account for overflow, not overflow, for the overlap. So overlap was 7, so we need to subtract 7 from that duration. That's going to be 3. So the result here going to be 3, and we need to add 0 equals 3. So total we have 2 plus 1, 3, 4, and 3. The total duration gonna be 10, and this is basically so if we have ending at 9, so like the total duration here, like it's like we have end at 9, so like 9 minus 0 plus 1 equals 10. But we made this allocation to every function. So every time we check that there is exhaustiveness in this algorithm. So like some of the of the kind of all of their timings for the functions equal the total time of their execution. It means that if there is overlap, we only account for only one function that's like ahead of the stack. Okay, let me start programming this approach. I already started doing that, but I didn't account for all for overlappings. So let's start accounting that for the first one is actually the index I see here. Yeah, the first one is the index. So if you have start, we push the 0 there. Yeah, and else if you have and, we need to pop it. Second of all, we need to find the duration. Int duration equals start 1, and then we'll have record. Let's say we have integer current equals say new equals just this array. And if we push just current 0, let's have a shortcut for that one. Current 0 and then current 1, and then we pushed it the stack, and then if there we have the start and then duration equals current 1 minus start plus 1. Let's have we have an output equals duration minus start or overlap. Account for overlapping, and then we output for the index char, let's say 0. Let's say we have if start 0 not equal current 0. Let's have throw new runtime exception, unexpected state reached, say this, and next output current 0, and then we need to record the duration in the if stack not is empty. We need to int top equals stack peak, and then top 2 plus equal duration. Okay, duration. And then we do this, and then in the end, okay, so in the end we're gonna wrap up, and in the end we need to return output. So that's it. Let's check if what's the case they have here. So they have here n equals 2. Let's test this more interesting example. In this case, we'll have this set. So it's array list. So let's say list. Let's say array list string logs call new array list string, and then we need to do this. Need to add this sets. Okay. And then expected output gonna be 7 and 0. In this case, let's check int expected output. 7 and 1. And let's say we have the solution. We call that function. Call it n and logs. Okay, arrays equals. Okay, expected output Java arrays, and we have array list. Okay, that sounds good and about to be right. Let's test it. So we have this input. We have record there. So let's have this. This is gonna be our stack. And for every, so at start we have a push get I. So we pushed what? We split it. We see the here's 2. We pushed it, like we pushed the value into the stack 0 and 0. So function 0, yeah, function 0, and we push it um, with overlap 0. And then we go to the next record. We are going to the record 2 here. So we pushed again 0 starts at 2 and then overflow 0. And then we have like this output also array. And then we go to end to, you see the next element is its end, 5 end, end at 5. So we do, in this case, we do stack pop. So we pop this element. Okay, we pop this element. We subtract end minus start. So like in this case, when they have end, one end, it should be like end at 5. Yeah, okay. So in this case, we do this, we pop this element, we subtract, so we pop this element, we subtract current end from the start plus 1. So like 5 minus 0 plus 1 gonna be 6. And it's gonna be the duration. And the duration, we check the duration overlap is 0, so we push that 5 minus 0 plus 1, 6, so the 0 becomes 6. And we get the top element, so now the stack becomes like this one. The top element is this one, 0, still 0. We add the duration to the overflow, so it's become like this. Duration is 6. Yep. And then we go again. Our pointer is pointing at 1, start 6 at 6. So we push 1, starts at 6, overlap is 0. And then we go to the next element, 1 and 6. We do this 1 and 6. We pop the current element, we pop the head of the stack, and then we 6. We subtract, to get the duration, we subtract the current from the 6 minus 6 plus 1, so duration will be 1. We add 1, output gonna be 1, 1. And then we get the top element and we add the overlap to 1. So the overlap is going to be 6 plus 1, going to be 7. Yep, and that's it. So we're going to go to the next element. It's going to be and 7. start at 0. So 7 minus 0 plus 1, 8, and minus 7. So we go here. So 7 minus, so with 7 minus 0 here should be duration. 7 minus 0 plus 1, 8. The duration gonna be 8, and we add the output as 8 minus our flow minus 7, and we add 6 plus 1 gonna be 7. So the output should be 6, 7 and 1 in this case. Okay, let's run it and check. Interesting. What's gonna be the output? Okay. Okay, output is equal 3 and 0. So there is some error here. Still. Let's try to debug this one. Let's try to think where I failed to do this. So the output, okay. Let's okay. So okay, pushing 0 at 0, pushing 0 at 2, pushing 1 at 6, and that's it. Okay. Okay, so here is like plus equal. I figure out this one. Okay. Let's remove extra variables. Let's check this. So actually it was the test number 3. Test 3. This one test 3. And this one test 3. So let's check the test number. It should be test here. Test number probably 1. Oh, it's gonna be more interesting. I guess this one gonna be more interesting. Yeah. Check it. Answer 8. Okay. So it's the same, only one function here. And it should be, what, 8? Yeah, it should be 8 here. Okay, let's test it on the Leetcode. I copy just inside this one function. Yeah, it was a little bit hard for me. I spent like 1 hour, 15 minutes to fully solve this problem end to end. Let's check what they have here. Hmm, interesting. So they have every time, so they have this deck of logs, and every time they add start, be all about this deck. I wonder if this log record stack, wonder if that in the actually in the solutions. Deck log again. Some kind of approach that's this one is more interesting. So they have stack. Whatever, I'll wrap up. Think I'll it's a home exercise for me. I'll try to check all these solutions and how do they solve it. But my approach is quite simple. So I have this overlap. No, actually, I don't need the overlap variable. Um, I have this overlap addition proxy variable that I save next to the records in stock and stack that has a start, the index ID, the function ID, and the start time. I also save the overlap, and whenever I need to finally calculate the size of it, I subtract n from start plus 1 minus overlap, and anytime that another function is called in the scope of the current function, I add that duration of that inner function to the overlap variable of this outer function. And that gives me this solution. Yep. Yeah, solving this problem in 1 hour 15 minutes is a little bit fail for the job interview standard. So I'm gonna wrap up.